Objective, cubes and cube roots. Definition number 1, a perfect cube is the cube of a whole number. So a cube means it's raised to the third power or multiplied by itself once and then multiplied by itself again. So 1, 8, 27, 64, 125, and 216, you need to memorize these. These are the first 6 perfect cubes. And they are perfect cubes because 1 times 1 times 1, so it's multiplied by itself 3 times, comes out to be 1. 2 to the third power, or 2 times 2 times 2 is 8. 2 to the third power is 8. So 8 is a perfect cube. 3 times 3 is 9, times 3 again gives you 27. So 27 is a perfect cube. 4 times 4 times 4, 5 times 5 times 5, 6 times 6 times 6. These are perfect cubes. Now the numbers 1, 2, 3, 4 that give you the perfect cubes are not perfect cubes themselves. Okay? The result is the perfect cube. Definition number 2, cube root. A number when multiplied by itself and then multiplied by itself again equals the number under the radical. So a cube root. The cube root of 8 is 2 because it gave us 8. 2 times 2 times 2. The cube root of 64 is 4 because 4 times 4 times 4 is 64. So here's how we denote a cube root. It looks like a square root, but in that little nook there's a 3. It's a smaller 3. It's not a big 3 out front. It's called the index. Okay, so that's the cube root symbol. Vic number 1. You can use perfect cubes to estimate non-perfect cubes. Example number 1. 4 to the third power is 64 because 4 times 4 times 4 gave us 64. 7 to the third power is 343. It's 7 times 7 times 7. You multiply it by itself and you get 49, and then you multiply it by itself again, so 49 times 7 is 343. Example number 3. Negative 5 to the third power. So this is negative 5 times negative 5, which is positive 25, times negative 5 again is negative 125. So negative 5 to the third power is negative 125. Now you can type these into your calculator. You need to put parentheses, and to get an exponent, make sure you're using this key. It's on the right side of the calculator near the clear button, and it's called a caret. Not like the carrot you eat, but spelled differently. Alright, and that will give you the exponent. So if you were typing this one in, it will be negative 5 in parentheses, press the caret key, and then a 3, and hit enter, and you get negative 125. So that's calculator type. Example number 4, the cube root of negative 1,728. So we need to think, what number got multiplied by itself and then multiplied by itself again to give us negative 1,728. So negative 12 times negative 12 times negative 12 gives us negative 1,728. A cube root of 729 is 9 times 9 times 9. So the cube root is 9. The cube root of 64 is 4 times 4 times 4. So 4 was multiplied by itself and then multiplied by itself again to give us 64. So the cube root is 4. Cubes and cube roots are opposites of each other. Vic number 2. Unlike square roots, the cube roots can only have one answer. Square roots, remember, we could have the principal square root and we could have the opposite. So we could have a positive and a negative answer. But for cube roots, you can only have one answer. And it may be positive or negative. Alright, so the cube root of negative 125 was negative 5. The cube root of 64 would be 4. So either a positive or a negative answer, but not both. Estimating cube roots. Not all cube roots are perfect cubes. In these cases, you need to estimate which consecutive integers the cube roots fall between. So a consecutive integer like 3 and then 4, 7 and 8, they have to be in order, consecutive. Determine which two integers the cube root falls between. So example number 7, the cube root of 56. So I'm thinking about the list that I asked you to memorize at the beginning, so the list of 6 perfect cubes. And I want to know which two numbers in that list 56 falls between. So 56 falls between 27 and 64. So the cube root of 27 is less than the cube root of 56, which is also less than the cube root of 64. So I choose the two numbers from my list. Now the cube root of 27 is 3, because 3 times 3 times 3 is 27. The cube root of 64 is 4, because 4 times 4 times 4 is 64. So if the cube root of 27 and the cube root of 64 have the cube root of 56 in between, then when you take the cube roots, the cube root of 56 must be between 3 and 4. So we can say, therefore, the cube root of 56 is between 3 and 4. Alright, we can do the same thing here. So the cube root of negative 182. So again, I'm thinking about my list, but I'm thinking of all those numbers as negatives. So negative 125 and negative 216. So the cube roots of these. And I wrote them in the reverse order because this is actually smaller and this one's bigger because they're negatives. Remember, the closer it is to 0, the bigger the number actually is. So the cube root of 216 is 6. So the cube root of negative 216 would be negative 6. Negative 6 times negative 6 is 36. Times itself again, so times negative 6 is negative 216. So the cube root of negative 216 is negative 6. The cube root of negative 125 is negative 5. So if this cube root of negative 182 is between negative 216, the cube root, and the cube root of negative 125, then it's actually between negative 6 and negative 5. So we can say, therefore, our 3 little dots in a triangle, therefore the cube root of negative 182 is between negative 6 and negative 5. And I wrote it smallest to biggest, just like I did here, 3 and then 4. So using your graphing calculator, here's how you can do these. You press 3, because the cube root is a 3. Okay, when you do the square root is already implied that the index is 2. So on this one, the cube root, because we have a 3 out there, so go to your home screen, press 3. Then you're going to look for the math key, and that's on the left side of your calculator, math, and option number 5. So option number 5 looks like a little X and then a radical sign. Option number 5. And then you're going to type the number you want to find the cube root of. So if you type in negative 125 and then press enter, your calculator will tell you negative 5. Okay, so those are the steps for using your graphing calculator.